Welcome back. In today's lesson, we're going to extend what we've been doing with solving to working with fractions. So these are going to be equations that have fraction, either coefficients or denominators, basically. So I know a lot of us have strong feelings about fractions, and that's okay. Fractions are really tough. And in this lesson, I'm going to show you a way to handle these fractions in a pretty consistent way that hopefully makes some sense. So first, before I get started with problems, I sort of want to talk about how we can remove a denominator from a fraction, because that's the whole goal here. This target is to remove the fraction so we can have an equation that makes sense that we can solve much easier. So let's take a look at this 5/4 and 4/6 here that I have. So how do I remove the denominator? Is what this is going to show you. So I've got 5/4 here, 5/4. If I didn't want that 4 to exist and I just wanted it to go away, what I can do is I can decide to multiply 5/4 by 4/1. And I'll show you why this works. So I've got 5 times 4 on top, which is 20, and on the bottom 4 times 1, which is 4. And what is 20 divided by 4? It is 5. And look at that. The denominator has gone away because I multiplied by 4/1. The reason I multiplied by 4/1 is because 4 is the denominator. So I decided to multiply it by 4/1. I have to do it over 1 because I can't just multiply a fraction by any old number I want to. I've got to make it look like a fraction. Okay. In that same note, I can also talk about this being noticing that we have this 5 as our answer here that we got, and that we had a 5 at the beginning of the problem in part of the fraction. So by multiplying by that denominator, I got rid of the denominator and I ultimately ended up with the numerator, which is 5. So if I do the same thing over here, what number would I multiply the 6 by? The 4/6, I'd multiply it by 6/1. When I multiply the top, I get 24. Multiply the bottom, I get 6. 24 divided by 6 is 4. And look at that. It got rid of the denominator and left me with the numerator. So it removes the denominator. We can make a note of this. It removes the denominator and can leave the numerator. So this is sort of how we're dealing with equations with just one fraction. It removes the denominator and leaves the numerator the way it was. So let's take a look at example 1, letter A. So I've got 1 equals 3 plus x over 10. I've got this 10, and before I do any moving around or any solving, I want to get rid of this 10. Since there's only one fraction here, I can go ahead and multiply both sides by 10. And I'm going to make sure I draw my line down the middle like I've been doing with previous solving. When I multiply both sides by 10, effectively the 10 cancels out. Just like up here, the 4 sort of canceled out and left me with 5. Okay, so the 10s cancel out. On the left side, I have to actually do this multiplication here. This 10 times 1, that's math I now have to do, and 10 times 1 is 10. Bring down your equal sign, and what you're left with is that numerator 3 plus x. The 10s have gone away, so you're left with 3 plus x. You're not multiplying that 3 plus x also by 10. The 10 canceled, so you don't need to multiply the top by 3 plus x. Now this is something that's easy to solve. It doesn't have any fractions. It just has that x plus 3 on the right, so I can just subtract the 3 on both sides, get 7. And x, and my answer is x equals 7. Okay. For letter B, the only complication is that I have a denominator plus 2 other integers. What makes this one a little bit different is that I've got this 8 hanging around here. I don't just have one fraction on one side and a whole number on the other side. So I need to get rid of this -4 in the bottom here. So here's this -4. He's kind of pesky. I don't want him there. So I'm going to go ahead and multiply everything by -4. And when I say everything, I'm not just going to do this. I'm not just going to say, okay, times -4 here and times -4 here. I also have to multiply that -8 by -4. So I have to multiply every single term. By the denominator. Okay. So what this looks like is for this, these cancel out and I'm just left with that x on top. Then I've got to do this multiplication. I've got to do -4 times -8. -4 times -8 is +32. And then on the right side, I need to do -4 times -4, which is +16. So that's the other math I did, is I did -4 times -4. Now again, I've got an equation that all the fractions are gone. It's not as overwhelming. I can do this. I can subtract the 32 on both sides and get x equals -16. Okay, so that's how you deal with an equation that just has one fraction in it. You multiply everything by that denominator, all the fractions should go away, and you're left with an equation that is simpler to solve. Okay, so let's move on to what happens when we have equations with multiple fractions. So equations with multiple fractions are a bit harder, and they're harder because you don't just always have just one number in the denominator. So I'm first going to show you an example of what it looks like when you do have one number in the denominator. So example A, I've just got, notice, every single fraction in this problem has a denominator, oops, I don't know why I did that, has a denominator of 3. So that 3 is the denominator everywhere, so I can multiply every single number here by the 3. Oh, it keeps doing that. Let me get my different pen here. There we go. So times 3, and times 3. What this does is it's going to cancel out the 3 in the denominator, and it's going to leave you with the numerator. Okay, so I'm going to keep that negative in front of the 10, so -10x. Keep that negative with the 5, so -5x. Draw your line down the middle, equals -5. So I'm just left with numerators. And just like that, I have an equation that's much simpler to solve. The other thing I want to show you here is that when we looked at these fractions, and in fact, I'm going to erase this little bit here of the crossing it off. Okay, so I'm going to leave the highlight, but I'm going to erase crossing it off. And I'm going to show you that, let's say we want to use our calculator here. Let's say instead of just assuming that the denominators cancel out, I want to use my calculator. What you can do is you can go ahead and put this in parentheses, and we're going to do this a little bit later, but I want to show you now, and use your calculator. So this is like saying -10/3 times 3. Well, if I go to my calculator and do parentheses -10 divided by 3 times 3, which is what the math I'm doing, I get that -10 still. I still get that numerator on top. I'm just double checking in my calculator that that fraction work is correct. So that's really why this is working. Okay. So I'm showing you that here, and I'm also going to show you that on another problem as well. But you can also just remember that if it's the same number you're multiplying by, they do just cancel out. So in this problem, before I start moving anything over, I've got to combine like terms. So I get -15x on the left because these are like terms, so I can combine them, equals -5. And now be really careful here. We're not dividing both sides by 5. We're dividing both sides by -15. Okay, so x is not going to equal 3. X is actually going to equal 1/3 because 5 divided by 15 is different than 15 divided by 5. If I go to my calculator and do -5 divided by -15, I get this decimal, math, enter, enter, I get 1/3 as my answer. You're going to get fraction answers in this learning target, okay? So I'm going to put that, you will get fraction solutions. Okay, so letter B has a few things going on that make it a lot different. In letter B, you're going to notice that you've got two different denominator values. You've got this 4 here, and you've got an 8 there as well. So you've got two different numbers. You can't now just say, I'm going to multiply everything by 4. Okay, it doesn't work that way. Instead, you've got to find a common denominator. So this is where things get a little bit harder. So you have to find a common denominator. So in this problem, you're going to ask yourself, what does 4 and 8 oh, sorry, not what does 4 and 8, but what number does 4 and 8 multiply into? Okay, so when I'm looking at the number 4 and 8, I'm asking myself, what number does 4 and 8 both multiply into that's the same? So I'm looking at the number 4. Does 8 go into 4? No, there's nothing times 8 that goes into 4. But does 4 go into 8? Yes, 4 times 2 is 8. So that's my common denominator. So what I'm going to do is I'm going to go ahead and now multiply everything by 8. So this gets times 8, this gets times 8. And something that a lot of students forget is this little negative 2x here that doesn't have a fraction. It also has to get multiplied by 8. When we're multiplying both sides of an equation, every term has to be multiplied by whatever number you're picking, or it won't balance out each side of the equation. Okay, so now that I've picked 8, I'm going to go ahead and do all my multiplication. So this first 8 times negative 2x gives me negative 16x. The next thing I'm going to do is I'm actually going to draw in my parentheses for this one, because technically what I'm doing is 8 times 5/4. So I'm going to go to my calculator and do 8 times 5/4. If I can get my calculator app to show up, there we go. So 8 times 5/4. Remember to put your 5/4 in parentheses when you plug in, hit enter, and you should get a whole number. And I did. I got 10. That's awesome. So I got 10. So this becomes plus 10x. And then on the right side, I have negative 29 over 8. Well, these 8s just can cancel, and I can get negative 29. If you don't like to remember those just cancel because it can get confusing with multiplication, just go ahead and multiply in your calculator. Negative 29 over 8 times 8. So negative 29 divided by 8 times 8. And boom, I still get that negative 29. So either way you want to think about it is fine with me. You might want to get in the habit of using that calculator work to help you find your fractions. So now that I have this, I can go ahead and simplify and solve. Negative 16x and 10x are like terms. So that's going to give me negative 6x equals negative 29. Divide both sides by negative 6. And when I put that in my calculator, I end up just getting positive 29 over 6. I'm not going to show you every bit of calculator work on this video, otherwise it would take a very long time, but you would put that in your calculator and simplify the fraction, and you end up getting 29 over 6. Okay. Let's take a look at another problem. Okay, this problem is unique in that we've got 4 different numbers that are denominators. We've got 4, an 8, a 2, and a 40. So this common denominator is a little bit tricky. And one thing I always do is I always check the biggest denominator. So in this case, my biggest denominator is going to be 40. And so I ask myself, does this 4 right here, does this 8 right here, and does this 2 right here all multiply into 40? And the answer here is yes. 4 times 10 is 40. 8 times 5 is 40, and 2 times 20 is 40. So they all can multiply into 40. I am then going to go ahead and multiply every single thing by 40, because that's my common denominator. I'm going to erase these arrows so I have some room. Okay. Now this looks kind of scary. You're like, whoa, 40 is kind of a big number that I'm multiplying by. That's okay. Your calculator can do a lot of this work. The only thing you're really going to have to make sure you do is put those parentheses around your fractions. Okay? Because that's how you're going to want to put them into your calculator to check your work. So the first one I do is negative 11 fourths times 40. So negative 11 fourths times 40, and I hit enter, and I hope I get a whole number, and I did, negative 110. And it makes sense because 44 does go into 40 20 times, so it does make sense. So negative 110. One thing to notice is that this has a little x with it right here. I don't know why it keeps doing that. It has a little x right here, so you can't forget that when you put down your negative 110, you also put the x with it. Now, I'm not going to show you all of these in the calculator because the video would take much too long, but trust me, that negative 15 over 8 times 40 is going to give you negative 75. At least I hope, trust me here. 1/2 times 40 on the other side is going to give me 20x, and then 159th over 40, these 40s cancel out like we talked about in the other learning target, and I just get plus 159. Now this is awesome because all my fractions have gone away, which is what we want. I want all the fractions to go away. So now that that's happened, I can go ahead and solve this like normal. So I'm going to go ahead and subtract 20x to get my x's on the left side. You are working with some bigger numbers here, but the concept doesn't change. You're still just moving the x's to the left, the whole numbers to the right. I get negative 130x, bring down that negative 75. Bring down the 159. Then I'm going to add the 75 to both sides. I get negative 130x equals 234. Divide both sides by negative 130. And when I put this in my calculator and simplify, I get negative 9 over 5. Okay. So check for check the biggest denominator, make sure the other three numbers are for however many other numbers go into it, and then pick that number to multiply everything by in the problem. This might not always work. You'll see in the next example. So in the next example, my biggest denominator happens to be a 5. But if I look at the other numbers, if I look at 2, 4, 3, and 3, 2, 4, and 3 do not go into 5. They just don't. So that means that 5 cannot be my common denominator. So scratch that. That can't work. So what do we have to do in this case? In this case, we have to find a number that 5, 4, and 3 all go into. So I could start sort of guessing and checking if I wanted to. I could say, okay, well, what about if I take the 5 and the 4 here and I multiply them, I get 20. So let's check 20. Okay, so does 2 go into 20? Yes. Does 3 go into 20? No, 3 does not go into 20, so that can't work. So 20 doesn't work. So when I start guessing and checking here, I could try 40, I could try 60, I could try a lot of numbers, but that could take you a lot of time. So my strategy is I would take your biggest numbers, the 5, the 4, and the 3, and I would multiply them all together because that's going to guarantee all three of those numbers go into it because they all are multiplied together. So I'm sorry, I'm erasing so much. So now I'm going to have, what's 3 times 5 times 4, and I end up getting 120. Then I have to ask myself, okay, I've got this 2 I didn't use. Does 2 go into 120? Yes, 2 goes into 120 60 times. So that means my common denominator, for short CD, is 120 for this problem. Now, I know that seems like a really big number, and it is a really big number, but it doesn't change how we do this problem. So we're going to go ahead and multiply and everything. When I say everything, I mean everything. So this by 120, 11/3 by 120, the 27/5 by 120, 3/4 by 120, the number 1 by 120, and that 5/2 by 120. It is a lot. So this is why I really want you to use your calculators, because you're going to really need them to do sort of these big calculations. I'm really interested in that you guys can come up with these common denominators on your own, and that you're able to type fractions into the calculator and make sense of them. In order to do that, you've really got to put parentheses around all these fractions. So I'm going to show you in the video here. Put parentheses around all these values, and then you know when you put them in your calculator to use parentheses and you won't make a mistake. So, and I'm not going to show you that right now. I'm going to just have you trust that I'm putting them in my calculator correctly, because the video would take too long. But when I go ahead and do 120 times -4/3 x, I get -160x. That takes care of that one right there. And sometimes I like to cross off to let myself know I'm done. -11/3 x times 120 is -440x. Done with that. -27/5 times 120 is -648. Don't be scared of big numbers. 3/4 x times 120 is 90x. Gone. 120 times 1, that is one that trips students up. They don't always see, especially if it's a 1. They might not see that one, but it is there. So that's just plus 120. And then finally, we've got -5/2 times 120, which is -300. Okay. So now I've got a nice equation. It's got big numbers, but hey, all the fractions went away, so that's great. I'm going to go ahead and start combining like terms now. So on the left side, I've got a like term here and a like term here. Both of those are like terms, so I can simplify -160 plus -440 as -600. Keep the x. On the right side, I've got the 120, the -300, and the -648 as my like terms. So I'm going to just drop down that 90x. -648 plus 120 minus 300 is -828. I want my x's on both sides, so I'm going to subtract 90x on both sides. These cancel out. I get -690x equals -828. Divide both sides by -690. I know these are big numbers, but when we get to the end and we put this in our calculator and simplify, we get 6/5. Okay. So this is probably one of the toughest problems that we will be doing in this unit. You've got to find that common denominator. You've got to be able to multiply all your terms by that common denominator correctly, and then you've got to be able to solve the equation like we've been doing this unit. So this really combines a lot of topics into one, but I know all of you can do this with practice. So please, if at any time in this video I lost you or you got stuck, come talk to me. Let's have a conversation. If not, go ahead and start the practice, and good luck.